Hello, and welcome to Season 2 of The Retort, hosted by me, Dr. Brett Edwards, who's based at the University of Bath in the UK. In this season, we will continue to examine some of the most pressing issues facing the global chemical and biological prohibition regimes.
So Nick, you've taken, like many people, a bit of a winding route to the issues you're looking at now, the kind of darker side of science, and in particular looking at the sort of military aspects and also security and ethical concerns around these technologies, and in particular biotechnology. So why don't you briefly kind of explain what went wrong and how you've ended up here?
So I did a degree first in physics and in nuclear physics in particular. And I was, as an undergraduate, I worked on a very small kind of fusion kind of diagnostic reactor. So smashing hydrogen atoms against each other to create helium. And while I was there, I did a little bit of reading about the history and philosophy of science and the history of nuclear physics in particular. Obviously, there's a dark side to nuclear physics. It might be the most obvious dark side of any of the scientific disciplines. And I got really interested in kind of disarmament issues. When I talked to the guy who would eventually become my graduate supervisor, one of the things he pointed out is that doing work on nuclear nonproliferation in Australia, which has no nuclear weapons program, has no nuclear energy program, and has one very small medical reactor that creates medical isotopes for kind of the Southeast Asian region, not really a great career move. So I made the even better career move to do a Ph.D. in philosophy. And Michael Sogalid, who was my doctoral supervisor, he was working at the time on a report for the Department of Prime Minister and Cabinet in Australia on the so-called dual-use dilemma in the biological sciences, which is something your listeners might be familiar with, the idea that ostensibly beneficial biological research could be used to help or harm humanity. And I went to do my graduate work at the Australian National University, which is where Ian Ramshaw works. Ian Ramshaw, of course, is one of the two guys who is famous for the mousepox experiments, where Australian scientists created a genetically engineered strain of mousepox that killed 100% of the mice that were infected and 60% of the mice that were genetically engineered to be resistant to mousepox. So I met some interesting people with colorful pasts. And I guess the rest is history. And like a lot of people, biological disarmament is really interesting, but it kind of comes and goes in waves. And there are moments when the field is very quiet, and there are lulls. And I entered into such a lull around 2015, 2016. I had been working in the United States at that point for 2 years. I had been part of the deliberative process on gain-of-function research in virology. I had spent a lot of time in Bethesda, Maryland, yelling at civil servants from the Office of Science Policy at the NIH. But I was kind of done, and I wanted to look at something a little bit not virology. And my postdoctoral advisor, Jonathan Moreno, in 2004 had written a book called Mind Wars, which was about the militarization of neuroscience, and especially DARPA's interest in neuroscience in the United States. And at the same time, one of my mentors, Malcolm Dando, was very kind of heavily involved in thinking about the ways that neuroscience was being used to kind of find new forms of toxins and other biological compounds which might influence the central nervous system. And so I kind of got sucked into this really small world of people who think about dual-use issues in neuroscience rather than dual-use issues in microbiology or synthetic biology or virology. And so that's what happened, and that's where the book came from.
Fantastic. So the reason I'm so excited is that brings us nicely into the first question I had. I read the book. I invited everyone to go and get a copy. It was very good. And so today we're going to go through some aspects that come in from that discussion, and hopefully we'll try and keep the general interest as much as we can, and it won't turn into I'm not sure what the metaphor is. There's a metaphor, but we'll come back to that later on. So, what's neuroscience? I mean, that's the first question. Is it
Yeah.
seems to be quite a no. So let's not go into the semantic nebula stuff, but as a kind of domain of area that militaries are interested in and of security concern, what is kind of neuroscience? What's the kind of scope of that?
So neuroscience, broadly speaking, is the scientific inquiry into all things the human brain. I mean, potentially animal brains as well, but the human brain is kind of really where it's at, because in part because it's the only one that we're reasonably sure is conscious. And that's kind of an interesting wrinkle for neuroscientists because they can map out a bunch of neural circuits, but how you get to consciousness is a much trickier problem, or a hard problem, as the philosophers would say. And the reason that militaries are interested in neuroscience is in part because all things national security eventually come back to human beings, and a lot of the battle, so to speak, in national security is about either overcoming adversaries by causing them to not want to fight you anymore, or figuring out what their plans are so you can stop them before things get really bad. So national security, kind of broadly speaking, that's criminal justice, the intelligence community, and of course the military, have had an interest in neuroscience and things that came before neuroscience, before we started delving directly into the brain, such as cognitive psychology and psychotherapy. They've had interest in this for at least a century, if not longer.
And what I found particularly interesting when I was reading the book, because obviously you read lots of books where it kind of becomes like just a menu of scary stuff.
Mm-hmm.
And it's kind of like, this is the stuff we could be worried about or should be worried about. What I liked about your book as well is, though, you talked about, I guess this is your philosophy background as well, is the fact you talked about this idea, and particularly as someone who's looked at kind of revolutions in biotechnology and how that over 100 years period is only just now kind of coming through in terms of its profound impacts on warfare and those sorts of things, is the idea that in the cases you looked at, and we'll go through, I think it's 4 case study areas you kind of went through. We'll talk about those in a moment. We talked also about how it's not just the tools and techniques developed by scientists in that kind of classic conception of technological emergence, but more fundamental ways of thinking, and planning and those sorts of things. So it's kind of much more epistemic, more profound impacts. And of course, with you touch upon AI, but of course this book was, I imagine, written slightly before the kind of hype bubble that we've seen around AI in the past year or so. So why don't we talk through a little bit some of these kind of key dimensions through which either neuroscience as a kind of an area of knowledge, or neuroscience technological, or sort of self-identified neuroscience-based technological systems have impacted upon this area. And to cue up your memory, because I know you wrote this a year or so ago now, that's prediction, which I think relates to intelligence, persuasion, warfighters, and neuroweapons. So let's work through those. And if you could squeeze in as many film references as possible to characterize, particularly some of the more hypothetical ones, I'd be forever grateful.
All right. Yeah, so the 4 broad categories I divide neuroscience up into for the purposes of national security's interest in the field. The first one, prediction, I think is really something that is underappreciated when we think about kind of the use of technology by especially state militaries, which is this idea that, often when we think about dual use, we're thinking about a gizmo or a bug that's going to do a bunch of horrible things to a whole bunch of people. But at the end of the day, one of the things that the military has a lot of interest in neuroscience for is understanding the way that people behave. And this comes out in kind of 2, I guess, broad domains. One is understanding how other people behave, and the other is understanding how their people behave, right? State military is, since antiquity, or, I mean, there weren't states per se back then, but as long as there have been standing armies, there have been problems of logistics. And the way that neuroscience can kind of help state militaries understand their own people is actually really, really useful for state militaries. So it can help them know what their decision-making capacities are under extreme stress. It can help them understand what their propensity to obey or disobey orders are. It can help them understand how they learn so that they can train them more efficiently. There are huge concerns, and we'll get to this with the warfighters in a bit. There are huge concerns about the ability to train and retain competent soldiers in the military, especially at the level of, say, the special forces, where soldiers typically have to be a lot better trained and are held to a much higher standard than kind of regular enlisted forces. But the other bit is in predicting the rise of an enemy, and this is kind of where we kind of see, I guess, the legacy of the war on terror kind of mix with neuroscience, which is that kind of post the war on terror, or I guess post 9/11, there was a definite sense, especially in the United States, but more or less across the world, that adversaries were increasingly distributed. They used non-conventional communication methods and tactics to kind of arrange each other, and kind of at their kind of most diffuse, there was this kind of emergence of what some scholars will call stochastic terrorism, which is this idea that, for example, the militant right wing will create propaganda, and they will effectively recruit people to their cause without actually directly recruit them. So, for example, the Christchurch mosque shooter in 2017, he wasn't recruited by an army. He was, but he was inspired by far-right ideologues. And so state militaries and intelligence services have a real interest in predicting when these people are going to kind of emerge, what they're going to do, what they're going to plan, and how to kind of locate them before they do anything. But that's really hard in the age of enormous social media kind of presence. Being able to kind of track down which Twitter accounts are the worrying ones, and of the worrying ones, which ones are the ones who are actually going to start shooting people is no mean feat.
And I guess in some ways, this is all a consequence of the interaction of the individual, basically the individual mind of soldiers and those sorts of things are integrated in increasingly large social organizations. So some of the stuff you were talking about a few moments ago with regard to kind of supporting the warfighter, we'll get back into that a lot, and understanding the psychology of people. A lot of that sounds like management, right? A lot of it sounds like the move away from personality-based management systems where it was very small teams, where leadership in itself was a very specific, so embedded in all of this is this broader cultural shift in military culture and those sorts of things as well. So what also struck me is that some of these areas inevitably are kind of quite forward-looking trends. But other areas, and for me, I always either follow the money or follow institutional collaboration. I mean, there are very concrete areas where neuroscientists and neuroscience institutions and ideas are actually already been co-opted and working within sort of military settings. Is that right? So in terms of prediction and intelligence, can you think of any sort of go-to examples where there's already evidence that this is kind of an institutionalized form of relationship, or that type of thinking is already important?
Yeah, I mean, so what we saw is in the early 2000s, we had this kind of development, and it was this, again, as we'll get to a little bit later, there's this synergy between artificial intelligence on the one hand and neuroscience on the other. And these two fields kind of play with each other and inform each other in kind of really deep structural ways. And so in the early 2000s, what we had was what was then called the Total Information Awareness Program, which was funded out of a number of US agencies, including the Defense Advanced Research Projects Agency, or DARPA. That was kind of met with a bit of public outcry because total information awareness sounded a little Orwellian, and indeed it was. But the fundamental mechanisms of that were taken apart, but they were ultimately given to the NSA, and they became what we later kind of referred to as Keystroke X and PRISM, and all of these mass surveillance technologies that were revealed by people like Edward Snowden in the kind of 2012, 2013 kind of era of the war on terror. It's often hard to think that like there were different controversies every year between like 2001 and 2015 when it came to the war on terror, and so you have to kind of order them precisely.
I'd have definitely gone for holistic over total. It sounds much friendlier as a label.
Holistic information awareness. That does sound more like management. Much more like something that a HR department would have, rather than a bunch of super spies.
So now the next one, which you managed to talk about in the book without mentioning Inception once, which I was very impressed with.
But I believe I referred to Batman at least once.
Batman was in there.
Yeah.
There were several different references which I very much enjoyed, and it's encouraged me to maybe think about doing a special in relation to that. So you talk about persuasion, and you talk about obviously the use of neuroscience to help understand the psychology of individuals and groups, but then also the more chemical-based approaches to, and there's quite a broad gambit there. And I know there's some overlap between them all. So in terms of the persuasion, what's the kind of central aspect of that dimension of this?
So one of the big programs that came out of the kind of prediction model was this thing called the Narrative Networks Project, which was pioneered by a friend and colleague of mine, a former DARPA program officer by the name of William Casebeer, who also has a PhD in philosophy. And the Narrative Networks program was really using neuroscience to understand how different not kind of propositional knowledge, so not just the mere communication of facts, but the way that stories are created to kind of marshal and mobilize facts into propaganda affect people's brains, and which stories are most effective on manipulating people in certain ways. But the logical consequence of that is once you know how to predict it, you can, in principle, then use it against your enemies, right? So you can create counter-propaganda, for example, to try and de-radicalize people, even as these stories are being used to radicalize them online. So that's kind of one area in which persuasion is mobilized using neuroscience, is trying to figure out which stories we can tell to undermine the propaganda that is being released to recruit people to various terrorist causes. And so obviously being a program that was run between 2006 and 2010, the dominant kind of interest at the time was trying to figure out how Islamic terrorist groups, Al-Qaeda, Daesh, were using stories and narratives to recruit Muslims to their cause. This has since kind of dovetailed in the last few years into understanding how white nationalist stories, for example, and white supremacist stories mobilize these kinds of militant groups, and then try to develop counter stories in order to kind of undermine those propaganda messages. At the much more invasive level, persuasion in neuroscience is thinking about how you could directly manipulate people's brains into accepting and absorbing information. And so while some of this is being done for training purposes, so understanding how you can pharmacologically enhance people to learn, say, to speak languages better, or learn to pass basic training better. It is also being thought of in terms of, the enhanced interrogation program, the U.S. torture program, and how neuroscience informs, developing relationships between interrogators and their subjects in order to better extract information and potentially deprogram people from their ways.
And it sounds like, I mean, just a sort of a slight deviance from the structure of the talk so far. I mean, it sounds a bit like you have, if you look at the history of different programs where you have military involvement in technology and technology development, sometimes it kind of, the impetus comes from military funders looking for fresh ideas and new inputs if they're looking at solving technical problems or building a capacity in a certain area. Other times it comes from fields where they go, well, you guys should be paying me to do this. It's good. And so that's quite interesting in thinking about that in terms of where the push-pull comes from. And also, I guess, the second point, which again we can mention now, but we'll come back to later, is the fact that the examples you've talked about so far are all US-centric, and there's a reason for that. It's not that you hate the US; it's that, generally speaking, if it's anything like sort of some of the areas I look at in terms of biotechnology, it's because they happen to be one of the more open countries, which means that we can actually look at who they're funding very often and much more readily than other states. So, I guess this is also something where some of these ideas you're talking about, the examples are drawn from the US, but we assume there's also active programs in other states. They may not be as large. We know that the US is a significant funder. But I just wanted to sort of segue that in before moving on to these other examples as well, in terms of just sort of going, I guess, we're talking about the US because the examples are there, but this isn't going to be just the US.
No, it's not just US centric, and there have been very large programs in other parts of the world, in France and Germany, in China, in the United Kingdom, to kind of unpack the human brain, as it were. And indeed, the Royal Society of London released a number of policy papers more than a decade ago called Brainwaves, of which I believe the third issue of that policy series was devoted to neuroscience and national security. So certainly other countries have been thinking about this. One of the reasons for focusing on the United States for me was that I was living in the United States at the time. The other, as you said, is that it's a much more open country in terms of what it acknowledges doing in terms of kind of science and security. But the fourth is that in terms of its magnitude, the United States is simply a larger funder of some of this securitized neuroscience than other countries are, and that's just a function of the size of its science and technology and the size of its military budget.
Cool. With that cool caveat then, which I thought was just useful raising, we can then move on to the next two, which get particularly well. I look at a lot of bleak stuff in my job, and some of this stuff is bleak in a very particular way of going, you're going to spend all that time and resource to do that. It's not just the aim of it, it's the fact the fact that we're so willing to entertain some of these ideas because they serve as the apparent security function, which I'm sure some will. So the first one we've got here is the super soldiers advancing the warfighter, which of course most people start with Nazis on amphetamines. That seems to be their go-to analogy, and of course, as you point out in the book, historically, caffeine, mascarin, all sorts of things have been used in militaries to kind of enable and alcohol and coffee have been used to enable soldiers to operate in usually very inhospitable conditions. So why don't you talk? So not to ruin the surprise, but there's obviously drugs, and there's also other areas as well where you're talking about the use of neuroscience to improve the warfighter.
Yeah, so I mean, war has been fueled by drugs for as long as we've been doing war, really. Łukasz Kamiński, who is a Polish author, has an amazing book called Shooting Up, which is a history of the use of drugs in war. It's a fabulous book, and all of your listeners should go and get that book before they get my book, because it's a really worthwhile read. But one of the things that he points out is, whether it's kind of Athenians using alcohol to kind of suppress their inhibitions when it comes to murdering people from other city-states, through to Vikings on kind of effectively on magic mushrooms, through to sub-Saharan African warriors imbibing lethal doses of caffeine. We say, as we kind of use our performance enhancements to get through the morning and afternoon respectively, people have been on drugs in war for a very long time. My favorite example is actually Finnish commandos who would carry tubes, one of which had amphetamines kind of dispensed on one side of the tube, and the other which had opiates dispensed on the other side of the tube.
I remember in the book you mentioned that the heroin example, I think it was the Scandinavians. It was you were saying that it was initially prescribed for obviously pain and those sorts of things, but by the end of it, basically heroin, the soldiers were using it seemingly for all sorts of ailments, be it altitude sickness, or one imagines if they'd been a bit if they're sort of bowel related things, and then one also imagines just also because it's heroin, and so it sounds like that was very widely available during that conflict.
It was. So Pervitin was a form of amphetamine, and then kind of heroin and morphine were widely available. And one of the reasons why is that low doses of opiates can actually work to suppress vasoconstriction in your lungs, right? So we often think of opiates as depressing your respiration, and that's certainly true if you take them in high enough doses. But in very, very low doses, it actually kind of calms your breathing, which is really useful if, for example, you're going into shock, or you are potentially suffering from hypothermia, which is obviously a risk if you're a Finnish commando in Finland, killing Russians or Nazis, depending on the day. And so, for a very long time, Scandinavian countries had a very harm reduction approach to the use of opiates, in part because they were seen as medically necessary. And also, you can bring someone back from a heroin addiction. You can't bring them back from hypothermia that kills them. We do not yet have that technology. We certainly didn't in the 40s. And so, these drugs were seen as necessary parts of a warfighting effort, in ways that we would be much more, I think, circumspect now about their use.
And the book surprised me that you mentioned that some of the use, particularly of amphetamine stimulant agents, continues today. I mean, it's kind of authorized for certain accepted forms of use where it's kind of protocol. You're allowed to administer these things. I'm not sure if it continues. This example continues today, but I think you mentioned long range flying in certain situations. It's seen as necessary. And what was the main? There was a main type of drug that is the most kind of prescribed in this context, isn't that right?
Yeah.
I think.
Yeah. So modafinil is the kind of drug of choice of the U.S. Air Force these days. And that's not actually an amphetamine. So that's a this is where neuroscience comes into it. So this is a replacement for amphetamines. So dexamphetamines have been used by pilots for a very long time in order to stay awake in long-range missions. Again, there are obviously risks to taking long and large doses of amphetamines, but there are substantially greater risks of flying your plane into a mountain. Again, we can bring you back from an amphetamine problem. We can't bring you back from flying into a mountain. And so, these are risks that pilots have taken for a very long time. They are now risks that are codified in the military medical literature about how you assess someone before you put them on amphetamines and how many amphetamines you give them. They're euphemistically referred to as go pills in the US military, and then there are no-go pills, which are the drugs that you give people after they get back from flying to allow them to sleep, right? So you give them some amphetamines to keep them awake, and then when they get home, you give them some Ambien to put them back to sleep. Modafinil is a cool little drug in the sense that its actual mechanism of use is not widely understood yet by science. But as far as we can tell, rather than kind of exciting your adrenal system and your nervous system to kind of stimulate you. So as a stimulant, what it does is it prevents the release of the chemicals that tell your brain that it's tired. So it down regulates all of the norepinephrine and other stress hormones that your brain creates under conditions of extreme fatigue, so that you do not feel the effects of fatigue over They've tested this over 30, 60 hours of continuous wakefulness. I happen to be a once and former user of modafinil. In 2020, I was prescribed it because I was caring for my wife who was very ill, and I was also going up for tenure. And I was also in the middle of a pandemic like we all were, so there was not a lot of sleeping happening. And I was diagnosed with what in the United States is called shift work sleep disorder.
Yes.
And I was prescribed modafinil to kind of get me through that period. So I have some first person kind of phenomenological research
Yeah.
on that particular drug. And where neuroscience really comes into this is that there's an increasing demand not just to find a chemical that seems to give us a particular output, right? So there's a book by the title is On Speed, and it's a history of America's relationship with amphetamines. America has had a very long relationship with amphetamines and a very complicated one. But one of the things that we find today is it's not just enough to find a drug that we can kind of measure a particular output from. We want the biological mechanism behind it. And so neuroscience is enabling us to figure out exactly which drugs suppress which chemical pathways or excite which chemical pathways in the brain, and give us fairly deterministic effects. And one of the reasons that we want this is that, especially in war, one of the risks of putting someone on high doses of amphetamines is that you're going to make them pretty aggressive. Now, that might sound good for people, who are like, well, what's wrong with being aggressive in war? Surely that's a good way to stay alive and a good way to kill the other guys. But as we have seen over the decades, it's also a really great way to kill people that you're not meant to kill, such as in friendly fire incidents. And there's a very famous friendly fire incident, which is the Tarnak Farms incident from the Iraq War, which has been partly blamed on amphetamines, and that was in one in which I believe it was Canadian soldiers were fired upon by their allies who were seen to be under the effects of amphetamines for a long-range mission. So Tarnak Farms is kind of a great example. Again, as with a lot of legal cases, it's not totally clear that the amphetamines did all the work there, but it's believed they certainly didn't help. So neuroscience is wanting to kind of improve that.
Yeah, and I guess there's two other things. The first was that a big issue you pointed to is, where do you draw the lines between medical and medical or kind of supporting medication or treatments and actually enhancement, and what that actually means? Does it actually mean anything? And those questions. And the other one that you talked about, which brought to mind, to me at least, was there was a Black Mirror series, and they had one of the episodes was where the soldier found out that they were wiping his memory to remove the memory of the things he'd done, and he basically got given the option of did he want to get it back or not. And so it was just kind of discussion about the nature of post-traumatic stress disorder and military and those sorts of things. And in your book, you talk about some of the different types of work, and some of that does seem to be medical, so almost like preemptive, helping people be more resilient to the stress that they're likely to experience in conflict zones. And some of it also seems to be beyond that. And you talk a bit about particularly what I would refer lazily to like cyberkinetic, integrating the deeper forms of integration between the human brain and the information systems around them, or new forms of integration, or new ways of harnessing the brain by the digital world, and new ways of the brain harnessing the digital world as part of decision making and those sorts of things. And that's a vast area, of course, but maybe it's worth just briefly sketching some of the key aspects of that.
Yeah, so I mean, one of the kind of pharmacological areas that people are really interested in when it comes to the brain and national security is how we use medicine to allow people to better process traumatic events. So this can be post-traumatic stress disorder, which can arise in civilian life as much as it does military life. And indeed, within the military, a lot of post-traumatic stress disorder is not from combat operations. For example, there is a kind of a vast problem of post-traumatic stress from sexual assault in the military, just like there is in everyday life. But then there's also moral injury, which comes about when soldiers do things that are antithetical to their own personal beliefs and kind of moral norms. So this might be shooting combatants who are underage, This might be shooting perceived combatants who later turned out to be non-combatants, and then also, obviously at its most extreme, the commission and complicity in war crimes. And so one of the areas that actually this is kind of dovetailed into is the kind of reemergence of psychedelics research here in the United States as a way to address PTSD. And there have actually been very positive clinical studies that have come about that. But the thing that everyone is obviously interested in neuroscience is, as you kind of hinted at, the brain-computer interface, which is the ability for people to be connected to computers or anything that runs on a computer via a chip in their head or via kind of a set of devices that allow people to read their brain states and potentially write new brain states into them. So at the moment, brain-computer interfaces, whether they're invasive, so you actually implant a chip in someone, or non-invasive, so you use a headset to read someone's brainwaves, they tend to be almost exclusively of the read variety. So we can read your brainwaves and we can convert that into a signal that a machine understands. Often this is used for example, quadriplegics in order to enable them to pilot wheelchairs. I believe there are something like 65 to 70 people in the United States who have brain-computer interfaces for that reason. But the holy grail of this is the ability to then write back into your brain, right? So, right now we could implant a brain-computer interface into you, and you could use it to control, say, a webcam, right? To kind of, move it around. But we don't yet have the power to take the optical data from the webcam and then pipe it back into your brain so you see what the camera sees. And that's something that, DARPA and other military agencies have put down hundreds of millions of dollars at this point to try and figure these technologies out, because that would give you the ability to be able to read and write information into the brains of intelligence analysts or warfighters, or whomever else you wanted to give one of these devices.
Oh, lovely. And we're in safe hands there. It always seems to be that at the moment, a lot of it just seems to be in the hands of military funders, which is, I guess, comes with its own questions and certainly types of suspicion and types of public relations and those sorts of things. And you say you touch upon that in the book as well. The final one, which is one actually that you were incredibly timely with, as the last episode interviewed. Well, we had a presentation from Michael Crowley, who was talking about bioregulators and toxins and various other chemical nasties, is neuroweapons. And so that's another theme you talk about in the book, and you cover a range of issues there as well. So what do we mean by neuroweapons?
So I pick out two kinds of neuroweapons as kind of the paradigms of what we might understand as kind of, this kind of fancy phrase, neuroweapons. And there is a real kind of habit in the space around neuroscience of people to just slap neuro on the front of other words, because everyone loves a good branding exercise. But the two kinds of military applications that I pick out that are kind of explicitly weapon or offensive kind of base, one of them is understanding small molecules that regulate the central nervous system. And we've seen instances of this. The breaking of the Moscow theater siege, obviously, kind of is one of the most famous examples of the use of small molecules gone very, very wrong. And that was widely believed to be a derivative of carfentanil, which is an analgesic. But we could imagine more exotic compounds that affect the central nervous system and cause fear responses, that cause pain responses, that cause euphoria. There was I believe Chandra Gould has documented that part of the South African Project Coast program was the attempted weaponization of psychedelics. So the attempted weaponization of compounds like MDMA and LSD. So there's increasing, as we get better at creating molecules that trigger very specific responses in the brain, we get closer to the possibility that someone could take those small molecules and then weaponize them for use as non-lethal or lethal chemical agents. And of course, Malcolm Dando and Michael Crowley have been looking at some of these gaps in our chemical and biological non-proliferation schemes, especially around the creation of riot control agents for use in domestic law enforcement, and the way that that can trickle into state militaries. But then the other, yeah, go ahead.
I was just going to look. So, and indeed, dear listener, if that is of interest to you, Michael and Malcolm have both produced a book which we look at in the last episode, where they go through those legal and military issues in significant detail. So, if that has piqued an interest, I would certainly go back and have a listen to that if you've not already. Sorry, I was being hosty. Carry on.
That's okay. But then the second kind of weapon that I identify is that once you implant a chip in someone's brain that is connected to a computer, that person is ostensibly vulnerable to a series of attacks that look more like we might think of in kind of cybersecurity, but now applied to the human brain. So the dominant paradigm in cognitive psychology, I believe, is still that the brain is essentially a very squishy, very complicated computer. And once you hook that up to a much less squishy, but potentially equally complicated computer like an artificial intelligence, you have the capacity to hack a person's brain in the way that you might hack a computer. And so I entertain like what some of these things might be. So one of them, and the most simple, would be something like a denial of service attack. So you basically, if you have a brain computer interface that can read and write, then one possible outcome of this is that an adversary could simply pipe nonsense into your brain computer interface and overload it. We don't know what that would look like from the perspective of the person who has the brain computer interface, because it's never happened.
It would be a lot like Twitter.
It would be a lot like Twitter, but directly into your brain. Yeah, like so, imagine the worst parts of Twitter, but you can't just close the app. Not that any of us really ever close Twitter, but Twitter is forever. But the next one that I think is really interesting, and here comes the pop culture references that you've been so desperate for, is this idea that you could a colleague of mine referred to it as data poisoning the other day, that you could pipe spurious data into a person's brain computer interface and give them false beliefs about certain things. So you could give an intelligence analyst the wrong set of information in order to make them make the wrong decisions. And interestingly, we don't actually have a good sense of how the brain would be able to distinguish between information that's coming from one source in your brain computer interface and information that's coming from the other. And to understand why that might be, this sounds like I'm turning into a Buddhist. I mean, I am a Buddhist, but this is not kind of a Buddhist podcast. But we don't necessarily have a good sense of where our thoughts arise from, right? The thought that, you wake up thinking at 3 a.m, as I'm sure some of your listeners do, we don't have a good sense of, my spouse said that to me 5 days ago, or that's a thought that came from Twitter, or that's a thought that came from the news. And so you could imagine that someone could insert a thought into your brain computer via your brain computer interface, and you would have no real knowledge of whether that's your belief or whether that's a belief that someone's put into you. And I think that this is a really kind of this obviously happens already, right? Propaganda, that's how propaganda works.
And of course, it probably reveals something about my parenting approach. The first thing I thought for me was, that sounds a lot like how I raise my children.
Right.
In terms of some of the beliefs and the irrational beliefs you see them pick up over the years, which you go, oops, that might have been me.
Well, and it's how we deal with people a lot of the time, right? Is we tell them something and we don't necessarily expect them to act on it because we told them. We expect them to eventually have it as their own idea, right? And so I'm sure we've all had this conversation with our children or our spouses or our friends where our friend has gone, I think I'm going to start going to the gym in the morning rather than the gym in the afternoon. And that 3 weeks ago you had that conversation with them, but now they've had that idea for themselves, and you get to be like, yeah, that's a really good idea because I had it for you.
So this is Inception then. This is Inception.
Yeah, basically. I mean, this is Inception, right? you wanted that movie reference, and here we are, right? Is, you know, this idea of giving someone another thought as if it were their own. Because the brain is, as some philosophers would call, encapsulated, which means that it kind of plays these tricks to feel like it's a coherent whole, right? Your consciousness feels whole to you, and so if someone puts a thought into your head, your brain is going to naturally kind of claim that thought as its own, rather than kind of recognize it as an intruder.
Perhaps unfair to ask, but how, out of curiosity, how close are we to actually being able to see a thought in the brain in terms of forms of visualization, or I guess more destructive approaches to removing ideas from the brain? Do we, in like, so you know, I assume that a lot of this is to do with fMRI type stuff, because you mentioned in the book in particular that, particularly you mentioned neuroscience, the central thrust of discussion has often been fMRI, understanding brain, electrical brain function in the brain, and then correlating that to functions or interventions. And so I assume with things like ideas, there must be a because this moves above Pavlovian type training. This is literally trying to look at changing the highest level structure of the brain to reflect changing ideas and those sorts of things.
So we can using fMRI, we can detect kind of emotional states, right? So we can kind of, but they're very, very broad, right? We can say like this region of the brain lights up when you do X, you know, and using deep brain stimulation there, or and also transcranial stimulation of the brain, which is putting electrodes on the side of your head. And I mean, it's kind of electroshock therapy with extra steps. We can kind of, it seems like we can enhance, for example, you know, certain kinds of mathematical abilities, or we can excite certain emotions, or dampen certain emotions using these kinds of stimulation. But we are still, I think, decades away from being able to, you know, show you a map of the brain and go, when you think of your child,
yes,
this is the pathway. You know, this is like, you know, this is the, you know, my sister is about to have her first kid, right? And, you know, so like, you know, this is Nick's like niece pathway, right? You know, down to the neuron. We're still decades away from that, in part because we do not yet have a complete and deterministic model of the human brain in the way that, I mean, we don't even have like an association-based model of the human brain like we do an association-based model of the human genome, right? And we know how long it took to get even just the basic kind of, you know, the basic kind of human genome model took what, 13 years to get, I think, 70% done, and then another decade to get the next 30%. You know, we don't have anything like that for the human brain. So we're still, I think, 20 to 50 years off from being able to kind of make those kinds of individual thought-based determinations.
Okay, so what I'm getting from that is that the film Inside Out, which is a great children's film about sort of in the life of, which I've watched many times, that may still prove to be accurate. That's what I'm taking from that. I've been a positive Percy, and that's a well. Thank you for that in terms of explaining that for me. It's a fascinating aspect. Now, so there's a very broad area, each of its own history. And I thought we should probably talk about, and I guess we've only really got time to kind of surf across these issues, but a sense of, I guess the so what question, it's in terms of thinking about what types of concerns seem to be meriting response or public concern. And then I guess questions about what types of response are we seeing? And I guess we could end on, because of course you've written a book on it, so you're forced always to comment on these things. You talk a little bit about what your vision of this, and your sort of idealized vision of the future of this area might be, in terms of the sort of thing you'd be happy to see happening in terms of identifying and responding to this issue, and ensuring kind of what oversight or governance might look like in this space going forward in the future.
Yeah, so I mean, I think the so what problem is really important in neuroscience, right? And part of that is because of what philosophers like Neil Levy, who's an Australian philosopher, would call the extended cognition problem, right? Which is this kind of idea that, you have your cognition inside your head, but then there's a whole bunch of stuff around you which aids you with your cognition, and the degree to which, there's this question about the degree to which that is kind of relevantly part of your cognitive process or like separate from, right? I often refer to my phone
Yes.
as kind of my extended mind, because I can't function without my calendar. That's just not a that's not a thing anymore.
Yep.
But let's take torture, for example. Torture with neuroscience is still bad, right? And nothing about neuroscience seems to make torture worse than it already is, right? Thumb screws and sticking needles in people's brains are still bad in kind of the relevant ways. So
Yep.
in some ways, neuroscience doesn't give us a lot to worry about, except that there might be new, interesting ways to torture people,
Yep.
and we should be just as outraged about those new, interesting ways to torture people as we are about waterboarding, or the like. The human prediction, section, I think, is more interesting because right now we don't have good deterministic models of social behavior. And so if neuroscience can get us good deterministic models of social behavior, then I think we have something new and interesting, that we might want to regulate on the level of nations or even internationally, because, we do have this intuition about mass surveillance being a really bad thing, but predictive mass surveillance seems like it would be an even worse thing. Right now, the NSA scrubs, metadata from everyone on the entire planet. Most of it is garbage. Most of it is useless. And it's not totally clear that actionable intelligence comes from any of it. But if someone were to have a good deterministic model of human behavior, then maybe that might be something that they could use, in ways that we don't want them to use it. And then brain-computer interfaces change the relationship between humans and machines, in a ways that we can't necessarily kind of capture yet. I can read misinformation and I can form beliefs, and you can look at the misinformation and go, well, that's clearly where he got that from. But all of a sudden, if it's being piped into my brain directly, then we have kind of interesting questions. What I would like to see, I think there are kind of like a couple of asks that I make in the book. One of them is around kind of national legislation. And I think some of the national legislation that I'm looking for really kind of comes into its own when we think about performance enhancement. Right now, no country, as far as I know, has good regulations on how we research performance enhancement in systematic ways. And so one of the arguments that I make is that we know that people are going to pursue for performance enhancement. They've always pursued performance enhancement. It's kind of it's a historical thing for thousands of years that people have pursued. But just like medical interventions over the last 50 years have, become more regulated in how we marshal evidence to say that this is an effective or an ineffective medical intervention, I think that we have to have the same process going forward with performance enhancements. And then kind of on an international governance level, I think that, one of the things that I kind of puzzle over is the degree to which we need, for example, new conventions, right? There have been talks about, do we need a convention against the military applications of neuroscience? The problem with the military applications of neuroscience is that neuroscience kind of is a field that touches on a lot of other things, right? So as your former guests, Michael Crowley, Malcolm Dando, have pointed out, there are a lot of application of neuroscience which are kind of picked up by chemical and biological disarmament processes already. When it comes to brain-computer interfaces, this might be something for the CCW to take on, but it's not clear that we need a new convention kind of on neuroweapons, for example, because the two examples that I've given us, one is really a cybersecurity issue, and we've already got people working on cybersecurity at the international level, and then one is a chemical and biological problem, which we already have instruments for. But I do think that those instruments need to take on these kind of future applications in sensible ways. And so, for example, getting the committee as a whole of the CWC or the BWC, the Chemical Weapons Convention, the Biological Weapons Convention, to take on advances in neuroscience, I think, is a really important step moving forward. I know that we've just had the 9th Review Conference, so the jury's out on whether we're going to do anything. But that's what I would hope for in the future.
And of course, that is more than a technical question about coverage and scope. it's also about the question of where we are historically at the moment in terms of the type of institutions that can be built and who's going to be building them. Exactly. And this idea of we can piggyback stuff onto existing institutions, and we can also more charitably work hard to reveal the continued relevance of certain institutions to certain new issues. But we're going to struggle to replicate the architectures of previous generations, and new forms of architectures are kind of, and they're not a zero-sum thing. But that's something I certainly, tried to get my head around in terms of thinking about how this era will be remembered in terms of, if we, by progressive people who look at kind of progressive institution buildings, what the role of this era has been in that kind of, what's the long arc towards a bit of Whig history, the idea of development or maintenance of norms and laws of war and those sorts of things. So yes, I think that was really useful. And I really do suggest people go out and then read the book. I like the fact that you had you were very honest at the beginning in terms of where the book came from, and you also resisted many of the jokes I would have made, which I think is an admirable thing. There was very few puns. I mean, so not necessarily a good thing in everyone's eyes, but for me, I think I saw that as a very great exercise in self-restraint.
As you intimated the other, kind of earlier, there's this kind of trade-off between the number of puns and the number of movie references you want to make, and I chose one path over the other, right? You kind of can't have both if you also want to have content in there.
That's true.
So neuroscience is one of those things where, like, I mean, we've been talking about this in pop culture for so long, right?
Yeah.
All the way back to Blade Runner and even before. And I think that, readers probably already have some of these examples in their mind. And sometimes, I mean, some of these issues are really abstract, right? Once you get into like philosophy of mind and problems of consciousness, it might be better to just kind of point to a movie and be like, it's kind of like that. Rather than, especially because I wasn't writing this for philosophical audiences, it wasn't necessarily something that I wanted to get too deep into the weeds on.
No, I think the books are better for it. I personally felt I learned a lot from it, and I thought that the way in which you managed to skim across such a broad domain and make sense of it and link it together was fascinating. So thank you very much for that. So Nick, we've managed to keep this within an hour, which I think is good, and I think that's a good thing. So I think all that's left me to say, thank you so much for coming on today. It's been a pleasure speaking to you, and I really wish you best of luck with your future projects. What are you working on at the moment?
I've got a book coming out in May on the ethics of public health and pandemics, which I wrote during the first stage of the pandemic, which was not a great idea psychologically, but we all make mistakes.
Sponsored by the tablet, I've already forgot its name, whatever it was called, the stimulant that's not an amphetamine. What was it called?
Modafinil. Sponsored by Modafinil. Absolutely.
Great stuff. Okay, Nick. Well, that's wonderful. So maybe at some point I'll be able to bribe you to come back on here and talk about that book once it's out. But,
wonderful.
Really lovely speaking to you. Take care, and I'll speak to you soon.
All right. Thanks, mate.
Bye-bye.